Hello and welcome to Butterfly AI, also known as BAI platform, powered by Matricast Software UK Limited. In this video, we are going to explain the hyperparameter tuning process on this platform. You can use your own personal dashboard to perform the steps of high parameter tuning optimization and then programmatically call the models that you have prepared to execute inferences and prediction. In this video, we also show how to achieve an account fraud detection accuracy of 94% for a set of unknown and unlabeled accounts with F1 score of 88% in just minutes. While performing end-to-end machine learning operations in a serverless, secure, self-hosted, and scalable environment. Avoiding today's expensive AI ML cloud infrastructures, reducing ML costs by up to 90%. Welcome to future. The entire process described in this video can also be automated through programmatic calls to our BAI API endpoint. This endpoint would be described in another video. In order to know more about programmatic calls through BAI API endpoint, please watch the other relevant video. Thank you. So let us first define the F1 score. The F1 score is a machine learning evaluation metric that represents the harmonic mean of precision, minimizing false positive and recall, minimizing false negatives, providing a single value to measure a model's accuracy. A perfect F1 score is 1. In this formula, TP is true positive, FP is false positive, and Fn is false negative. This is an example of account fraud data that you can use for training the model for account fraud detection. The data includes information such as credit history, payment history, housing, fraud history, and age, and more information of the individuals with and without fraud history. The first column is ID of the data. The last column is what we know as a label of data. It shows if user has potentially fraud activity in the account. To know more about the unacceptable CSV input CSV format for this platform, please watch the 2 minutes video provided on our website. The next step is to log in into BAI platform. Okay, we have now logged in into the BAI platform. Please click on datasets. You will be taken to the dataset screen. In order to create a dataset, you need to click on create here. please give a name to your dataset. We call in this case fraud data 2, and this is the first hyperparameter that you should assign to platform. We have 3 hyperparameters. Number of buckets is a hyperparameter used by the priority algorithms on this platform to bucketize the data into some beans. We always recommend starting with the number 20. Then you can upload the data. For this case, we go to basically to find the data here, which is account fraud, and all I need to do to click open, and now the next step is to click the save to start the process of creation of the new dataset. As you click on the save, you're going to be taken to the dataset screen, back to that screen. Here you see all the logs of the past datasets that you have created. And you can see the process is going on, so we wait until the process is complete. Okay, the dataset is now created, and you can see your log here. The next step is to use this dataset, which is cleaned and prepared for training of your new champion model. All you need to do is to click on training, and you will be taken to the training screen. On this screen, you need to create by clicking on create, of course. And now you can see 2 more hyperparameters here. The 4 priority algorithms that we have, they are not using today's learning technologies like deep learning or other non-machine learning algorithms. They are using a novel and disruptive way of learning called cellular learning. The scaling factor here helps these algorithms to define the size of the cell. The next hyperparameter is called performance threshold. This performance threshold is telling our platform when to stop the training. For example, in this case, if platform reaches the 80% accuracy of training, then it would stop the process. There are many different ways to optimize these 3 hyperparameters. So what we are describing in this video is a suboptimum way of optimizing those, which is one way of doing this. We always recommend starting with these 2 values, 90 for scaling factor and 80% for performance threshold. Now choose the original dataset you have created and you are intending to use for training. As you click on save, you're going to be taken back to the training screen, and you will see that 4 underlying priority algorithms are going to compete with each other. The winner algorithm is going to be the new champion model. So let's wait and see what happens. As you can see, number of our algorithms are coming back. One of the algorithms already hit 80% here. You can see that the other algorithms are catching up. We wait until the process is complete. In minutes, you're going to have a new champion model. you can see the first attempt of training was successful. Here, the test data is an unseen, unlabeled data created from your original training data. And test performance and training performance, you can see how close they are. That means very little overfitting. And achieved performance is the average of training and test. And you can see we have created a new champion model, and this is log for that champion model. Next, we attempt to go a bit more ambitious with this training. Let's go for 85%. Click on create and choose 85. Same data set. As you click the save, you're going to be taken back again into the training screen. And we wait until the process is complete. Okay, within minutes, two of the preparatory algorithms managed to achieve 85% accuracy. And you can see we have a new champion model. Now, let's go even higher. Let's go even more ambitious. This time, we're going to go to 90% accuracy. Okay? As the process starts now, we can see that how fast, again, the algorithms are going to try to achieve that performance of 90%. What is remarkable about this platform is that we are running these preparatory algorithms right now on Google Cloud Platform, not on GPU, but on normal 4-core CPU. That means that we can potentially save a lot of power here and costs. Now, you can see one of the algorithms already leaning forward, and it's hitting already has hit 90% in just maybe less than a minute. This is remarkable, as I said, because it means reduction of costs and also speed of decision making. Crucial for lots of business applications. Now, let's wait and see where we end up with in terms of both test and training performance. That process was also successful, and you can see that the new better champion model replaced the old one. It's very important to note that we have managed to keep the very low gap between training and test. That means a very low overfitting. And also note that we are a serverless platform and we don't use this is no code process. So that means that you wouldn't require a large data science team to run this all. And you also avoid the infrastructure cost for running this training and all the process associated. Now, the next, we go even higher. This time, we're going to go to an ambitious goal of 95%. Click another training. So let's save this. This is the age of a green AI, a greener AI, more environmental friendly, more ethical, and more fair. Because when we have the high F1 score, that means that our AI and ML fairer towards multiple classes involved. Now, let's see how well the algorithms are going to be doing with this 95% goal. You can see that they are showing some progress. This algorithm is leaning forward towards having 95%. Let's wait and see when this process is going to end. Okay, in this case, we haven't managed to hit the target of 95%, but BAI platform is smart enough to realize that with these hyperparameters, it wouldn't be able to hit this target of performance. So it avoids running the platform for hours, and that means you can save a lot of cost, cloud costs related to running this process of training, as you have a control on when to stop the training. Many or most of the today's deep learning or other machine learning technologies lack this level of control that BAI and its underlying intelligent, novel and disruptive threshold, performance threshold mechanism provide. They lack this capability. And this is one of the key advantages of this platform. Now, also, you notice that the champion model hasn't changed because we haven't managed to hit. We're still at 90% the previous champion model. But the key here that you can see we have returned the all four proprietary algorithms, knowing when to what level they have been successful. The most successful algorithm here you can see is this one, which has achieved 94%. So what we do, we go a bit lower, fine tune. We create another training. This time we go to 94%. And we use the same data set. Let's see where we're going to end up with this training. Okay, within minutes, the process is complete, and we successfully managed to have a new champion model, which has achieved 94% training and almost 93% test accuracy. Now, we can go and tune another hyperparameter. For example, let's go back to dataset, and this time create another dataset. But rather than we call dataset different name like fraud data, we call another name 3, and this time we give 10 as number of buckets. You can assign 10, 30, 40, 50 steps of 10 or maybe 100 or any number between 4 and 100, and which are allowed. Now all you need to do is to drop the same file as of account fraud data. So this is going to be a new data set. Account fraud data, we open it, and when you save, we're going to have a new data set. Okay, we are back to the dataset dashboard. Let's wait and see the final result. The new dataset is created based on the new hyperparameter. Now we go to training, and the aim is to see if we can close the gap a bit between the best training performance and test performance here. So let's create this time another training. Of course, this time we go to the same 94% target, and the dataset is new one, which is fraud dataset 3. So as we say, we're going to start the process. As you can see, the algorithms are advancing. This algorithm is very close to already hit 94%. It's in such a short time managed to achieve 94%, and the rest are also progressing. The training is done, and you can see that in terms of the new champion model, we managed to achieve a better test performance, and we managed to close the gap a bit between training and test. So we can now continue this process of hyperparameter optimization by, for example, going after this third hyperparameter, scaling factor. Change the value and to see, to explore if we can get better results. The next is to use this champion model that we have here for batch predictions, to create batch prediction and fraud detection. Now, all you need to do to go to the prediction screen by clicking on prediction, and now click on create. The data set is the latest we created, the best model associated with that. And then all you need to do is to upload the prediction or fraud detection file. This file has a very similar structure to training data. This is the test data, except that the last column is missing, which is natural, which is obvious, because we want to predict if something is fraud or not. And in terms of batch prediction, it's crucial to note that the data structure should be exactly the same as the structure of your training. Now, the rest of columns basically, except that, as I said, one column is missing, the last column. Now, as you say, we're going to get back to the prediction screen, and we wait until the prediction is done. This process is going to be quick. Okay, the batch predictions are done, and all you need to do is to click on download to have your prediction results as it's shown here. We applied the F1 score formula I explained earlier to this prediction result, and we have managed to achieve 88% F1 score, which is significant for this unseen, unlabeled fraud detection of individuals that we don't know if they have or they don't have basically fraud activity in their account. So thank you very much, and that's our hyperparameter optimization on the BAI platform. Meet BAIs. BAIs, the new era of ethical, human-centric, explainable, and greener predictive AI. For more information, visit us at our website. You can discover new content in the website. Very important to note that, as I explained before, all the manual process explained in this video can also be automated through automatic programmatic calls to our API endpoint described in another associated video. And you can also follow us on LinkedIn. Thank you very much.